Somebody is saying last code. Okay. The data set remains as it is. It doesn't matter if you are doing it for the first time or the second time. I think this is something which you should know how this is working. That I asked you all to copy the data set. The link was given to you. So either you copy the link here in place of this location, you copy the link. That will also work, or you have to take the path. While taking the path, you have to make sure that you will use forward direction, the forward slashes. Instead of using backward slashes, you have to use forward slashes like E colon, then forward slash data, and then you have to take the path, which is automobile price dot raw. So the same data set, whatever you have used it in your pandas plot, the same you can copy paste here. On the same data set, I will be continuing the further topic as well. So I'll keep the same data set here. And if you have not downloaded the data, then wait for it. I'll just give you the URL link again. So you can just use the URL as a part of your data set. Just give me a minute, I'm just sharing it. Okay. So here is your GitHub link. In the special character, how to find it as in the last. So obviously you have to scan the data first. Even if it is large or short, doesn't matter. You can open them in some environment. You have to look for the data set. Generally, we solve it by replace function, regular expressions. These are the things which are used to handle those scenarios. But if you are saying that you will not able to see the data, then obviously you cannot find them. If a data set you have to scan and you need to find out if there is any special characters. That's why it takes time. Even if it is large, doesn't matter. Check for 100 lines, 200 lines, and see if the data has got any special characters. If the data is having special characters, you need to filter them. Usually, the regular expressions are used to handle these type of issues. Obviously, you have to look for them manually. Cure is done by the code part, and then you have to look for the data set. If you don't know what is the issue, then what you will cure it for. So as I said, we can do the scanning of, let's say, you can search for this particular column or every column, and you are like matching up if the data contains a special character. So that could be one solution. If you wanted to do it through the coding, you have to look for if the data contains any special characters like dollar symbol or question mark. So you have to keep on scanning them. It's like again that filter part, that if your column has got this particular value. Remember this what we discussed here in the filter part, the codes. Where is that? Okay, suppose this is what we are looking. Sorry, this is for column, right? Where is that value? Maybe let's say in this section, right? In this section, we are looking for to find out that if my specific column has got question mark, correct? Before you replace, before we replace, let us try to make a search operations here for this normalized underscore losses. So you have to look for this, that if we have got a normalized losses and we need to compare it if this is equals to question mark. Correct. Now wherever this will be found, we need to scan it. Now let me execute it and let me run it again. So this is how you can do if you wanted to write the code. And the same you can do it for the other values as well. Like for example, where it is saying, see, named, okay, yes, this type of thing should be placed under this inverted comma. Now you can see that we have got all those values where question marks are found. So this type of a scan you have to do. Similarly, you can search for if my data has got this backslash. So you have to manually do it. If you have got the special characters like dashes. Similarly, you can just change the value that if your value has got this type of dollar symbol, let's say dollar symbol, correct? So for every column you have to scan. If not, you wanted to do it through that other way around, correct? So you have to look for the different symbols, and with the help of regular expressions, you can then later replace it, or you can convert it in a different ways. So yes, you can write some queries, run some filter operations, and with the help of that, you can find out your solution. Clear? Now let me run it. Click on kernel, restart, and run all restart here. Okay, next part, that we have converted our data and we updated our columns into the numerical format. That is where we have ended up our details. Somebody was asking about explaining this last section. So see, uh, if you remember yesterday we talked about this type of scenario that apply function is there and apply map is there. These are the two part which is basically, so this apply part function will take your pd.to numeric, and this numeric part is nothing but it is about typecasting your data types. This is about typecasting to your data types, the existing data types in fact. Okay, so that's the way you can handle them, and this is one of the solution that we have. Anything else? So pd.numeric is pd.to numeric is typecasting. All right, so we were up to into the part of data cleansing, right? We were discussing about how to clean this data. So let's discuss that, the cleansing part. And this is what we will discuss first. So let's begin our proceedings. So first we figured out how to find out the number of missing values. Now that we have replaced it with a value here, okay. Suppose I wanted to discuss here about, that is one method of how to handle the missing values. How about if we wanted to clean the data by some different ways? And one of the different way when it comes to cleansing the data is by using the central tendency. By using the central tendency. So let's talk about here the central tendencies part. One method is just replace it by some value that we have discussed. This could be one solution of how to handle the missing value. Okay. Currently we have just looked for the count of the missing value. Yesterday we have seen it, that there are plenty of missing values are there. Now let's look for how to handle these missing values here. So in order to handle the missing value, we will look for first converting all these into the numerical form, especially these columns. That was what we did here. And once we have converted them into numerical form, let's see my auto price here. Let's see my auto price here. And in this auto price, we will look for, particularly to find out my null values here. Let's check the data types if everything was converted into the float or not. So yes, they have got converted into the data types that our desired data types are. So we can get started. This was our last code. Then after that, you can just take this auto price, auto_price dot data types. The next will be to understand that not all. Now, one thing could be, what could be one solution here is that we can drop these missing values. One solution could be drop these columns. If you will look at here, this normalized losses, this section normalized losses, the normalized losses has got 41 rows missing. We have got 41 rows missing. Okay. How many number of samples are there? We have got 205. Okay. Generally, if you are losing like 1 or 2% of the data, that is okay. But when you have just 205 rows and you are losing here 41 rows just because you wanted to apply drop rows, okay, just simply drop those rows, then there is a issue here. Then there is an issue here. We cannot drop these number of columns, these number of records, because it will not affect this particular row, but other rows will be also affected. Okay. So either one solution is drop this entire column, this normalized column, but is normalized column is important to us? Does it play an important role in our features? So that is subject to further details. As we will move ahead, we will study about that. But for the time being, if you are in a situation where you cannot drop the column and you have got a lot of rows missing, then you have to actually apply a strategy called as replace by central tendencies. So let's get started with our certain stats part. Now from here, this will be the introduction to your stats, because I think earlier to this we have not introduced anything related to the statistics part, but today there will be plenty of them. The first part in the stats starts with your central tendency. Different types of data type I have discussed, right? You all remember the different data types that we have covered. Like I'm talking about categorical data set, I'm talking about discrete data set, I'm talking about continuous data set. These were clear to everybody. And in the categorical data set, there were ordinal, there were nominal. These were the data. These were the further data sets, right? So hopefully you all remember them, because today I will be needing all these things, all these introduction part, especially the types of data. That part will be needed here. Okay, so if not, then just give me a second. I'll give you a quick flow here, that what are the different data types that we are having, and according to that we will proceed. The different types of data is really important here to understand, because on that basis we will decide what should be the strategy, what should be our strategy. Okay, so here is your one important details which is important, the types of data. So you should know about this part. This is your different types of data that we have. Remember, it is divided into two major categories. What is the other name of categorical data set? There are two names, right? The data is broadly divided into qualitative and quantitative. So where you will put this categorical part, qualitative or quantitative? Let's put them in qualitative. Next is, this is quantitative. Remember quantitative part, one is your qualitative part, the other one is quantitative part. The numerical one is quantitative and categorical is qualitative. Okay, the numerical one is further divided into discrete and continuous. So how we differentiate discrete versus continuous thing? How does we differentiate it? Discrete will be, tell me something about the discrete, which is, okay, limited range, short range, mostly integer. These are all mostly integer. Mostly integer, but this will be not always integer, okay? Mostly integer, but does not mean that it will be always integer. Limited range, short range will be there, obviously. Next is continuous. This could have any range of the data. It could be 0 to infinity, it could be minus infinity or minus infinity to plus infinity. So no limitation, any value could be there in this. Any value, any numerical value could be continuous. Examples: weight, voltage, sales, account balance, sensor stream data. These are all part of your numerical data. Categorical is divided into many subsections. Nominal. What is the meaning of nominal type of data? You can call it as names only. Names only. What is important about the categorical is, what is important about the categorical is that in this case there will be no numerical value. There will be no numerical value. It will be only about the string type of data. Like nominal, names only. Color of a hair, names. Marital status, gender, these are all names. Eye colors, city names, person name. So wherever names are involved, they will be considered as a nominal data set. Next is ordinal. Next is ordinal. Next is ordinal here. Ordinal data set will be considered as when the data is in order. Data set is in order. Okay, but remember the data set, if it is ordered, that still it will be in non-numerical form. Example, grades. By looking into the grades, you can say that you can arrange the data in such a way that they can be arranged or shuffled in an order form. Correct? This could be the order. If you have got the grades, they can be arranged or they can be ordered in this way. What could be the other example for this ordinal type of data? What could be the other? post in jobs, job postings, job designation, height in terms of categorical, height in numerical, it will be continuous, but height will be, in this case, you will be having height which could be arranged as tall, short. Okay, fine. So these are all your different examples for the ordinal data. There is one more category, one more you have to discuss, and that is called as dichotomous. What is this dichotomous is all about? Yes, feedback, average, good, excellent. These could be also there. So it goes with excellent here. Then you go with a good, and then you go with the average. Fine. Dichotomous is next. What is the representation of the dichotomous part? Dichotomous means only two categories. It means only two categories. This will be only two categories, which means you will be having a scenario of option A and B, like gender male and female. Male and female is an example of dichotomous. Similarly, you will be having a scenario of, true and false. You have an option A or B. Okay. Yes, in terms of vehicle, you can have front and rear. So when you have got only two, front or rear, which is the engine position, engine location. So when you have got just two categories, it will be considered as dichotomous. Okay, so this is important to understand for the next part. The next part is how to handle the missing values in these different data sets. If they are available in categorical form, if they are available in discrete form, or if they are available in a continuous form. So how to handle the missing values. You all are aware about the central tendencies, right? I'll just discuss them. The central tendencies. What are central tendencies here? Three values, mean, median, mode. Let us start first by the simple one, mode. Mode. What is mode here? Mode means most frequent, most common value. Most common value. So in this most frequent part or most common value, what you will do is you will simply be checking the frequency of the data, the most frequent value, and according to that you will decide that what is the mode in this case. Suppose I'll give you an example. Okay, just a minute. I'll give you a scenario here instead of going through this way. Okay, so suppose if I'll give you a scenario in this case that we are pretty sure that we are having a data and they will be particularly represented in this form. I'll give you a simple table. Okay, suppose this is my table here. What happened here? Wait a second, let me copy it again. Okay, so I think this is clear now. Let's take this. Okay, so this is my table. Now, by looking into the table, what you can do, in this case, what type of plot first you can make, if you just see here, in this scenario, the best thing is that you have to look for the most frequent value. So what is the most frequent value here? Most frequent value is vanilla. So what will be the mode in this case? Mode value will be 28. Mode value will be 28. Clear? That's what called as your first central tendency, which is called as mode. Okay. Next part is median. Those are beginners in the stats. Please don't hesitate to ask your questions. Okay. I'll expect that you guys remember them, as this is something which we have been doing from quite. I mean, we have used this in schools, so I'll expect that. Median is also known as 50th percentile. Median means 50th percentile. This means that if you have a distribution of the data, what is the meaning of 50th percentile? This means that if you are talking about, if you are learning about the distribution of the data, for example, median divides a distribution of scores. I'm talking about the test scores here of classroom exactly in half. Exactly in half. That's why it is called as 50th percentile. Mode is nothing but this is the most frequent value. So just find out the value count and see which is they having the most value. The most occurred value, the most occurred value out of all the samples. So suppose these are the sale details for the different flavors of ice cream. So which is having the highest count in the sales? Vanilla. So the total count was 28 in this case. Chocolate sale was 22, strawberry sales was 15, and so on. So you have to look for the maximum value count. Simple. If I need to do the mode part for the categorical data, how does I find it? So first of all, mode is applied to a categorical data set, right? So we need to look for here the categorical columns. Let's say body style is there. Okay. Let's say the body style is there. Now I wanted to find out that what is the most frequent body, what is the most frequent body style. So how does we do that? I just put this here. And I'll just simply do here what? I'll just take a column. Column will be body dash style, correct? And then what we can do here? We can just simply do value counts. Once you will find the value counts, you will see them. The sedan is having 96, hatchback 70, wagon 25, hardtop 8, convertible 6. So what is the mode in this case? What is the mode value in this case? Sedan, right? Why sedan is having the, why sedan is in mode? Why sedan is mode? Because you can see that it is the most frequent value. Okay, can we calculate it by the help of the data frame names? Yes, we can do so as well. Dot mode is available to us. So you just look at here, mode access equals to 1. Okay, I think only column is there. Now you can see in this case when you calculate the mode, what you get here, sedan, straight away it is giving you the answer of the category. Fine. So like this you can find out the mode for anything. Let me make this as a heading of central tendencies. Central tendency, this is the first in the stats. Okay, let me give you the answer. Median, 50th percentile. Median divide your data distribution of the test score example was there, so it will be dividing your data into exactly half, exactly in two halves. That's what the median means. And now we will try to discuss about the formulas here. So there are two ways of calculating them. One is in this case where you will apply it. By the way, median is generally applied to the numerical data, of course. Apply to the numerical data. Okay. How to calculate? How to calculate them? There are two ways to calculate. One was if it is even number, the number of sample. When a number of samples are even. For example, our samples are there like this. Let us write sample equals to 7, 8, 11, 15, 19, 21. So how to calculate the median here? Yes. Hopefully I have not discussed these things earlier, right? I have not discussed them, right, earlier. Anybody confirm it, please? Already discussed, I guess. Somebody saying discussed it. Somebody saying not discussed. I'm talking about the formulas. Okay, already discussed. Anyway, let's not go into the details. So formula is n by 2, n by 2th term, n by 2 plus n by 2 plus 1, n by 2 plus 1. These are the two terms that we have to take and we need to divide it by 2. So n by 2th observation and n by 2 plus 1th observation, and then we divide it by 2. This is for even. Remember, this formula is only applied for the even number of samples. What is n by 2th observation? Total number of sample is 6 divided by 2. What is n by 2th observation in this? N by 2th observation is third observation. What is third observation in this? 11. Third term or third observation. That makes it 11. So this n by 2th is 11. N by 2th is 11. Next is n by 2 plus 1th observation. So next one. What is the next in this? 15. Divided by 2. That's the answer for the median. So 11 plus 15, that makes it 26 by 2. This makes it 13, correct? So the median will be simple, the average of the middle term. If the number of samples are even, then we take the average of the middle term. If the number of samples are even, then we take the average of the middle terms. Next. When your number of samples are odd, when your number of samples are odd, when your number of samples are odd, okay, so we can take here my sample value, which will be given by 7, 8, 9, 11, 15. How many number of samples are there? When it is odd, then it is pretty simple that you have to take the middle term. So n by 2th position, simple. The middle term when your number of samples are odd. N plus 2th by, sorry, this has to be plus 1, no? Oh, this has to be plus 1. Because otherwise it will be not possible to divide them. N plus 1 by 2 observation. Fine. So you will just take here how many number of samples are there? 5, 5 plus 1 by 2, that makes it third. Third sample is 9. So simple. In this case, 9 is the median. In this case, 9 is the median. Okay. So these are all my values here. This is my two types of sample distributions here. If your number of values are even, then that's the way to calculate the median. And if your number of samples are odd, then this is the way to calculate them. Okay, so that's the way to discuss all these points. So if odd, your sample has to be sample order means we're talking about the data has to be arranged in obviously in ascending order first before we calculate the median. The data distribution should be in a proper order. It should be in an ascending order. Before you calculate these, please make sure that your data is also arranged in an ascending order first before we do any calculations. Okay, next. So we can find out median part. Let's apply it into my codes. Auto underscore price. Now this has to be applied to some numerical value, of course. So maybe we can try to find out the price. And then you will write simple here dot median. And it will return you the median here. This is your median value. Simple as that. This is your median. This is your median value. Next is obviously the simple one, mean. Mean we all know. Mean is nothing but it is our average. So that particular thing we can calculate it with the help of simple. You can take price and you can just write here dot mean, and that will provide you the average here. This is your median value and this is your mean value. Mean would be average. Average means how does we calculate it? So sum of values. Mean of samples. This is the way to represent it. X bar. And this will be given by number of samples. Sorry, sum of samples. I equals to 1 to n divided by n. N is your number of samples. I equals to 1 to n number of samples, and then we divide it by number of samples. Next part, so once we have calculated all this, let's try to understand that where to apply them. Remember that when you are applying or when we are discussing about how to handle the missing values using replace by central tendencies. So let's see them. Let's get started with handling missing values. Handling missing values here. So once you see the value here with auto underscore price, And in this situation, when we have got a lot of numbers value missing in this case, what we can do is we can pick our normalized losses. Okay, let's pick them, normalized losses. Once we have taken the normalized losses, we will apply here dot unique. Once we take the dot unique function, you see here nan value as well. Ignore that and you can see this is a continuous type of data, right? This is a continuous type of data. So once we have got a continuous type of data, what you can do is you need to particularly typecast the, this is a type object, right? This is a type object. You see everywhere, this is treated as a type object here. So first thing what we can do, what we will learn is how to convert, how to do the typecasting for a single column. So this I kept it so that I can teach you them separately. So typecast column from object data type to float or to integer, let's say. So we take here auto underscore price and my column name is normalized losses. Let's apply here my mean. So what I'll do here, I'll replace the nan by mean value. So everybody focus here, how to use it. I take my auto price, normalized losses. Replace can take three values. First, can take your replace function, we can take your np.nan. So I need to replace the nan value by what? By this mean value. And then we can pick here my in place equals to true. Now we did successfully replace the nans by the average of normalized losses, and we got the value here. Okay, so that's how it works. So if you will look at here, this is one way of handling the missing value. How to check if our missing values are targeted well or not, whether it is replaced or not. So isNull.sum. isNull.sum is returning you in this case zeros. Normalized losses from 42 is now changed to 0. That was our target goal. That was our goal in this case. Okay, I'm just sending it to all the participants. Start working. Once you have seen them, now what is next? Next here is that you can see that in this case we have got two missing values in number of doors. In bore you have got 4 missing values. In stroke you have got 4 missing values. In horsepower you have got 2 missing values. In peak RPM you have got 2 missing values. And in parts your price you have got 4 missing values. Total number of samples were 205. Now, one way could be like we can target them individually and we can replace it by the other central tendencies. But as you know that there is one more method which is there and that could be also used in this case is that we can simply drop these rows. As these are very less number of data is there. So even if we will drop them, there is no need for, even if we will drop these rows, that will not affect my value much because our total number of rows are 205. So let's see what becomes your new way of handling the missing data. So one of the method is drop NA function. Drop NA function does what? That it drops it so it drops the missing values, missing rows straight away. Auto underscore price dot drop NA in place equals to true. This will drop all your missing values here, and then we take my auto underscore price. So we took here my drop NA value, and then we check the shape. So from 205, our new shape becomes 193. So we have lost somehow 10, 11 data, which is okay. Why we have changed all NaN to mean? I'm discussing about the various strategies to handle the missing value. So this is we have to learn about the different strategy. This is one of the strategy that we apply. Now if it changes anything, those who are getting could not convert a string to float, check where you have made the mistake. Maybe somewhere you have missed us out something. I think you have not done these parts, the earlier part, and you are trying to straight away do the next section. So first execute it from the top, replace your question mark with a NaN, and then make the changes. Those who are getting the error of string to float conversion is not required. You guys have not completed the previous steps where we have replaced the data. In the data, we have replaced the question mark by the NaN value. That's where we have ended up our yesterday's part. And also, this was one more thing that we did in the end. And if you have not done these two sections, then definitely you'll get this error. So I'll reshare them. If you have not done, then do it. And this was previous step to all these steps that we are doing it today. And speed up, guys. Let's finish all our basic things by today so that in our next week we can start with our some more stats and machine learning topics or the data science algorithms. Okay, so these are different strategies going on, guys. Remember that I'm just discussing about assuming that here the data set I have taken, and these are the different strategies which are there, legal strategies which are used in the real world to handle your different missing values. So if your missing value will be of continuous type, you can apply the median approach or the mean approach. If your data set is categorical, then apply replace by mode approach. And there are some other methods as well. Okay, you can also replace it by some constant values, like by using fill NA is there. Some other functions are also there, like fill NA. So fill NA could be used to target the missing value, but in this case you have to specifically mention that what values you wanted to fill here. Okay, so do apply them and finish them. This is how the things could be done. And yes, so two strategies we have discussed till now. There will be a few more strategy I will try to discuss with a different data set, and there I will be introducing some important methods. Okay, I'll just discuss about how to particularly target our data transformation since our missing values are there. So I'm giving one more data set. I'll just try to change data set which is used in general practice for handling the missing values. So I'm going to take a data set which is known as where is it? Okay, I'm just sending you the data set. Okay, just give me a second. So here is a dataset link. Now either you download this data by using right click and save as. Either you save this data hopefully you have taken the data set. The next technique is imputation. Basic imputation techniques. One could be you can just apply the imputation by using statistics. By using statistics, what are the statistics strategies that it offers? Mean, median, and most frequent. Most frequent is obviously related to your mode of each column. With missing values. Next is imputation with a constant value. Imputation with constant value. Now, when you wanted to do the imputation strategy with a constant value, better in this case you have to rely on creating your own function. Okay, using def. In this case, when we are particularly targeting to apply the strategy of mean, median, and mode part, then for this we are having a library which will help us, and the library name is scikit-learn. Scikit-learn is quite an important library, and this offers us a lot of libraries that particularly help us in writing our machine learning codes, doing the data pre-processing. These type of things are made easy with the help of this important package, which is called a scikit-learn package, or sklearn in short. First of all, we will read the data. Diabetes equals to pd dot read underscore CSV. Either you can provide here the URL, or you can copy the data set from its location, and you can just provide the path. Remember, if you are taking the path, please provide the forward slashes instead of using the backward slashes part. Let me take the diabetes dot head function, and this will provide me the data which includes pregnancies, glucose, blood pressure, and plenty of nans are there, you can see. Sometimes the data could have zeros in place of nan, or question mark in place of nan as well. So that strategy I have already discussed, that in that case you have to look for the data, scan the data, and then try to figure out if we have got any extra symbols or any zeros in place of the missing value. That could be also often found. Okay, like to discuss about these missing values. So let's try to figure out how many data are there in your values here. So diabetes dot is null dot sum. I wanted to rearrange the data. So what I will do here is I'll write here short underscore values, and I'll write here ascending equals to false. Ascending equals to false. So this is particularly about reshuffling the data. Okay, start working on it. I think data red part I have already provided. Now in this case you can see how many values are there which are missing, correct? 1, 2, 3, 4, 5. So I can straight away now, there could be a scenario when you are having a lot of columns which are having a missing value, and you wanted to replace them by either continuous value or by median strategy. Let us imagine, let me just check for this insulin part, their unique value, and then I'll decide whether I will apply the mean strategy or the median strategy, because median is for short range and mean is for the continuous range, of course. That's how generally we decide. Insulin dot unique looks like a continuous value, though a lot of values are missing in this. You can see 374 rows are missing out of I think some 700 odd data will be there. Let me just check. Diabetes dot shape, 768 rows are missing. Sorry, 768 rows are there. Out of that, 374 is there. You can see that almost like 50% of the data is missing in this, which means that we have to apply, we have to definitely look for replacing these missing value in spite of straight away dropping them like this. Drop NA is the last option. Remember, this is the last option where we tend to drop the rows straight away with the missing value. To take here my diabetes value dot is null, sorry, dot replace. So at the first position we have to write np dot nan, At the second place, we have to write what? The mean of this, correct? Replace by mean because it is a continuous value. And do update them. So in place equals to true. And like this, your first part will be successfully handled. The insulin will be replaced by, okay, so some bit of issues here. We should have taken insulin here first. I think got miss. Okay, I have to do it again. Okay, now that makes it fine. So dot is null dot sum dot find out the unique values, then replace it by the missing value. Only target for the insulin column. So we are just targeting to replace the insulin value by the mean of the insulin. And then when you will check the null value of this, you will see that 374 rows which were missing are gone. Now we are left with only 227 rows. In skin thickness, okay, what should be the next strategy? The first of all, I like to show you the imputation method. So in the imputation method, I will take here a function called as from sklearn dot impute import. Function name is simple imputer. Function name is simple imputer. In this case, we will take a strategy. Strategy could be your mean. So you can either simply straight away write mean. You can also write median. And you can also write most frequent. Okay, first declare your function impute equals to simple imputer. Simple imputer can take your different strategies here. So how to know that these are the three different strategies? In this case, the best way is, oh, this is not working. What happened to this? Shift and tab. In the simple imputer part, okay. Now if you will look at here, we have got the default strategy. What is the default strategy? Mean. What are the other different strategies which it offers? Mean, median, and most underscore frequent. So most frequent is for mode. In this case, I like to apply this strategy as median. So you'll apply here a strategy. Strategy is simply could be applied as median here. Now what we will do in this case is that we'll take here data underscore array equals to impute dot fit underscore transform, and we can pass my data frame, which is diabetes, straight away. No need to write anything in this case. Just apply the data raw. Why I said that it has to be stored in a data array? Because the return type from this, fit means get trained, transform means apply changes. Please write down. Whenever fit is used, fit means train, and transform means apply the changes. This will be apply transformation. This will be apply transformation. Now, once we are done, we can just check it, and you'll see that all your missing values are gone. Why the value of insulin is showing 0? So what it should be showing once it's all missing value is gone? What this one is showing is null dot sum. So once all your missing values are gone, what it should return type here? 0. So what's the problem? Now apply the transformations here. Once we have applied the transformation, our all the data will be gone. Now, in this case, you can particularly target your, we have to typecast this data underscore array and also mention the column names, which will be from its previous data, diabetes.columns. Now, that's, you can say that that is kind of a drawback it has, that when you will particularly apply these fit underscore transform, the imputation strategy with the help of scikit-learn, the return type from this is an array. But you can just look at here that this is such a nice option that we have when your data, when you don't have any other choices left. Sorry, when you know that one type of a strategy you are applying into multiple columns, you can simply apply it to your data frame. And like this, all your missing values are handled. You can apply the imputation to the limited columns as well. When you will apply it to the limited column, you have to mention the column names. Okay, like in this case, you are passing the diabetes, right? Diabetes means all the data set we have passed. In whichever the column we have got the missing value, that will be targeted, and that will be replaced by their columns median. Okay, so what is the strategy this is doing is, imputation is simple, that it will check for the column, which column has got the missing value. So these are the column which has got the missing values. So they will pick these columns, and they will replace these columns by their missing values. Fine, and the strategy will be median, mean, or mode. That depends. Now that's how the things work here, and Somebody is saying that they are able to, so first of all, apply this pd.data frame. If you have not updated it, then obviously you will not able to see any values here. Now remember that in this case, you need to save this somewhere. Maybe you can just save it as diabetes underscore data frame, correct? So once you will save them, the values will be updated in my new data frame, and that's how it will work. Simple. So you have to update this one. If you haven't updated, then means you have to think about it, that how does we were discussing about the rest of the things. Whenever you make any changes, you have to save it. So that is a logical thing. You have to, even if I don't do it, you have to do, and then you have to check it for the rest of the values. So now if you will check, the updated value is neat and clean, and we can carry forward this my new data frame. So this is your updated value, which we have to save it. Guys, don't in this copy paste of series, don't stick yourself to only copying the code and then doing only that limited thing which I am doing. The logic will remain same, correct? So if I have not updated a data frame in any data set, then you guys have also not done the same. I mean, this is logical. If I am making any changes, you have to save it in some values. Don't just copy paste the thing, just keep your logic things also alive. That obviously we have to, if we have updated everything and this is our new updated data frame, you have to definitely apply the check to your new data set. In spite of you go to the same data set and you apply the changes. This will remain as it is. Either you update it in the same data frame, diabetes. Now, only one logical question I have found it here is that can we have in place equals to true in this case? So answer is no. That's the only logical question I have got. Rest all are just saying that you have not updated the data frame. Come on, you can do that as well. Result module, pandas has no attribute data frame. No, I think something is wrong in your code. Please re-execute it from the top. Please re-execute it from the top. Say then play on the all the others. Can we put a zero value instead of median as a strategy? Now, zero is not a good way of applying any of these things. Zero is never treated as one of these strategies. The strategy will be either mean, median, or mode. They are used, or it could be some constant value. I think that I have already written here that at the beginning, when I was writing here, that you can also replace it by constant value. So that is okay. Line number 44. Line number 44 is having just a simple package named as simple imputer, and we are applying the strategy. median, we are targeting to change or transform our diabetes columns. Which all columns will be targeted? These columns. So imputer function only targets for those columns which has got the missing value. Others will remain unaffected. Others will remain unaffected. So we will just simply apply here the changes, the transformation, and with this, our missing values will be gone. And how does it gone? So it will target this skin thickness. 227 rows are missing in this. So out of all these 227 rows, they all are replaced by their median. Similarly, in the blood pressure, we have got 35 rows missing. So these 35 rows will be replaced by the median of the blood pressure. Similarly, the rest will be replaced by the median of the body mass index, median of the glucose, etc. So that's what happens in the simple imputation part, and that's how we discuss it. So hopefully all have understood them, and that's one of the strategy. Now, rest all, as you will proceed ahead, you will learn more and more different methods. But these are the most commonly used methods: replace function, fill function, and imputation. The other could be like creating a customized function to replace the missing values. So that we can see in some example rather than applying here. So one, I'll take the example of some classification example. There I'll take some data and then I'll discuss it in a particular machine learning example. Okay, rather than discussing it in this form. So here I'm just writing those commonly used methods. Now, in order to clean the data, there is one more thing that, or in the transformation part, there is one more thing which is quite an important part, and that is your outliers, correct? Now, before we reach us to the outliers part, we need to discuss a lot of more statistical terminologies. So we have to again go back to our okay. Now, in this case, we need to look for some of the important descriptive statistics part. These are all part of descriptive statistics. What we are discussing is part of your descriptive statistics. Okay, let's get started here. Now, in this case, once we have talked about our data, okay, let us talk about two things first before we go ahead. And what are those? Population and sample, right? On one side we have got a population, on the other side we have got a sample. Remember, when you apply, whatever the things we apply it to the sample, and we perform our examination or hypothesis testing, whatever you do. This is your entire group, the large data set, the entire group here, the big size of the data. This generally represents your entire group of individuals, the entire data. Generally, the population has a large size. And due to this large size issue, we don't apply the strategies straight away to the population part. So what we do for a research purpose, for your research study, at the same time you can also call it as your hypothesis testing or your statistical study. We take sample out of the population. We don't target or we don't apply these research strategies on our entire population. What is a sample? Sample is your selected data is a selected data on which we perform examination. Okay, or we do is to research or study, or we do here the research or study. We perform the examination or the research or study. Okay, this is my two important thing that you have to remember. We target sample, we don't calculate it for the population. Whatever the research study you do over the sample, we assume that it will be true for the population as well. That's the basic understanding. That you apply the hypothesis, you apply your statistical study, mathematical research study over the sample, and that the result or the outcome will be true for the entire population. That's our assumption will be there always. So that's one thing of the descriptive statistics. Before I proceed ahead, I like to discuss here about histogram. I remember that I have already explained to you. So the next that I am discussing here is again is basically nothing but it is about your uh, extended version of the histogram. So histogram part we have already discussed that we take a range of interval and then make a plot. And by looking into the histogram, you can get the idea about the spread of the data, right? Similarly, we are having a lot of distributions, and one of the famously used or understandable distribution is called as normal distribution. Take here my normal distributions here. Normal distribution has got its important role in few algorithms. Okay, we assume that. So I'll just write it here. I'll explain them better when those algorithms will come. So let us first try to understand what is this normal distribution means. It is having a certain bell-shaped distribution. Bell-shaped distribution with a long peak will be there, a single peak will be there. And two tails. These tails part will be spreading towards the infinity value. So they will spread itself towards the infinity. Let us look here the distribution. These are your two tails which are moving towards the infinite side. Okay. How this distribution looks like? Okay, what is this? What is the importance of this distribution and how does it look like? So when you make this is nothing but this is again the same range thing and that histogram thing that we learned that we are having different range value. You can imagine that this could be your scores. I'm taking or considering here this as a score or marks of a student, and this is the frequency of the score between the interval. Same as we have learned in our histogram. Histogram is also a plot where there will be intervals of the scores and you will have the frequency, right? There will be one big peak here, and this peak denotes your most frequent value, right? But there is a catch in this case. This type of, if you say that your data is normally distributed, it means that your data is showing certain characteristics. The distribution will show certain characteristics. And what are those characteristics? It means that our mean, median and mode, all three central tendencies will fall on the same line. Normal distribution has got an alternative name as well, Gaussian distribution. Gaussian. So either you call it as a normal distribution or you can call it as Gaussian distribution. So what I said, all three central tendency falls on the same line. Let us imagine this value is 50. Let us imagine the value of this is 50. Okay. We represent it as by x value and x bar. Let us imagine the score is x, and I'll say that this is an x bar here. Fine. This is my hypothesis that I am assuming that my median value is 50. It could be 60, it could be 70, whatever the value is there, that will be all common. All three will fall in the same line. This is one part. Okay. If your data is normally distributed, it will be following up certain properties as well. What are those properties? Let's try to understand them. The rule is called as empirical rule. The rule is called as empirical rule. Okay. What does the empirical rule means? Empirical rule will be following up certain specific features. So let's say in this case, first of all, empirical rule. What an important part. Approximately 68% of the data falls within first standard deviation. Within first standard deviation. Within first standard deviation of mean. Standard deviation is calculated with respect to the mean, obviously. So that's your first point. Then second point, number 2, approximately 95% of the data falls within second standard deviation of mean. And third point is 99.7% of data will fall within third standard deviation of the mean. These are your 3 rules which are also the features of a normally distributed data. Also, one of the important property will be symmetrical. This will be symmetrical around the mean. Symmetrical around the mean, and you can call it here that mean will be equals to median. As you know that all three will fall on the same line. Symmetrical about the mean, in fact, a better word. Okay, so these are the properties. Now let's try to understand this first part section. Okay, so I'll just draw them here in the terms of plot. This is how it will look like. This is called as your first standard deviation. Remember, standard deviation is represented by the symbol sigma, and this is your first standard deviation. So we can just represent it in terms of x mu minus sigma. Okay, this is your first standard deviation. On this side, we'll be having minus first standard deviation minus first standard deviation. This is on the negative scale, this is on the positive side. So x plus sigma, and this will be x minus sigma. This first standard deviation, the negative first standard deviation will be given by x bar minus mu. Sorry, x bar minus sigma. X bar minus sigma. This is your first standard deviation. Second standard deviation. This is your second standard deviation. X plus 2 sigma. X minus 2 sigma. Next is my third standard deviation. This is my third standard deviation. And we can easily call it as x bar minus 3 sigma, and this part could be also said as x bar plus 3 sigma. Okay. So the description is also written here that the first standard deviation range, this will be having how much? 68% of the overall distribution of the data. Just actually remove them. Just remove them. Okay. What is the meaning of this? That when I say that it will contain near about 68% of the overall distribution, it means that, let's say if there were 100 students, out of that 68 student marks will fall under between this specific range. What is the range in this case? Let us imagine I will say that my standard deviation value is 10 for the time being. This is my assumption. And what is my mean value? Mean value is my 50. Okay. So what should be this particular value? X plus sigma 60. And what will be the x minus sigma 40. So it means that between 40 to 60, how much student out of 100 students who have taken the test, how much of the student marks will fall under this range? 68% of the total number of a student. So what is 68% of 100? 68. Okay. Hopefully I have understood this example, that what is the meaning of empirical rule. Similarly, the second rule says that we are having a value in this case, and that value will be 95%. This is between your second standard deviations. This is your second standard deviation part. Okay. So what is my second standard deviation here? Second standard deviation is, what will be the range of second standard deviation? 30 to 70, correct? Right now I have assumed that my sigma value is 10. So what should be my value here? 30 to 70. How much value will be? What is the total number of students? Marks will fall between the score range of 30 to 70. How many students range will fall under this? 95%. Right? 95% of the total number of the students, their marks will fall under the range of 30 to 70. Right? Imagine these are my assumption here. Okay? This is just no, this is my assumption that my sigma is 10 and my x bar is 50 in this case. What about the third standard deviation? Third standard deviation range will be simple, 20 to 80. So if a test is conducted 20 to 80, between this range, 99 students' marks will fall under this out of the over total number of 100 students. So that's the importance of this normal distribution. Through this, you can find out the distribution of the data. All right. Now coming back to the question of what is this standard deviation and how does we calculate it? So if you are having a sample given, then this will be dependent on, this is calculated by deviation of, by the sample deviation from its mean. Simple. Standard deviation has a formula, and the standard deviation formula says that we can represent it in terms of sigma. Sigma will be equals to, this is for sample. This is for sample. And the formula is sum of sample deviation from its mean. So xi minus x bar, divided by n minus 1. What is n minus 1 here? First of all, sigma is your standard deviation of sample data. Xi is your value or sample, each value of sample. Then n is your number of samples, total number of samples. And x bar is your mean of the sample. So if you will be having a real sample, from there you can easily calculate it. The function is straight away there available by the name of STD. STD function will return you the standard deviation value, which we have already discussed them in our statistical part. Correct? So that's how these terminologies are important. And now hopefully I've understood. Remember that standard deviation is giving you is particularly gives you the idea about the spread of the data. And when we say that we have to represent here the spread of the data, that means we are trying to calculate the deviation of the value, the deviation from its mean. We are looking for deviation of the data, and with the help of standard deviation we can get an idea about the spread of the data. Shouldn't the numerator will be squared? No, only the, sorry, numerator is already squared. Is it not visible? I think I made the correction already while explanation. Okay, so this is how the values look like. Now we can see here that my value of the standard deviation looks like this. Next is variance. Variance, and the relation between this and variance is that variance is sigma square, and it will be obviously represented in this way. Okay, again sum of the value, sum of all the number of samples that you calculate for all the number of sample I equals to 1 to n. We calculate it for I equals to 1 to n, and that's how it works. Alright, that's all about our standard deviation part. Next next part is our outliers from here. Now outlier part I have explained it earlier as well in terms of box plot. But before we reach to that part, we need to discuss here about one more term called as standard normal distribution. Now this is quite an important distribution part, which is standard format of the normal distribution. It's kind of a transformed. The earlier is that when you plot the sample, then you study it, that is called as your normal distribution. But if your data is not normally distributed, you transform them, then that is particularly called as your standard normal distribution. And this is somehow kind of a transformation part that we apply. And let's have a look into this part. This is an important section. We need to study about it, the standard normal distribution part. So in the measure of distribution, we discussed about the deviation part, the standard deviation. There are other measures which are also frequently used, which we will discuss as we will proceed ahead. So before we reach to that part, there is one more thing that we have to discuss, which is called as standard Gaussian distribution or standard normal distribution. See, the plot and everything will remain as it is. The only changes will be there on the x-axis side. In the earlier part, I said that the x-axis was, the x-axis value will be symbol related to your, just give me a minute. Let me just look for the plot straight away. I can take a plot, and on the basis of the plot, I can show you the value distribution section. Okay, standard normal distribution will look like this. On the x-axis side, we have got this time z-score. Z-score is the way of standardizing your data. In case if your data is continuous and it is not following the normal distribution part, this is one of the strategy, one of the pre-processing strategies that you can apply, okay, to your features to transform the data. And this transformation is called as your Z transformation. Using your Z-score formula. So how does we check it? We do it with the help of Z equals to x bar minus mu upon sigma by under root of n. That's the Z-score value. Standard score. You can also, okay, wait a second. We can also say it in this term, no? X is not there. This is both are mu. Okay. Let me change the x minus mu, and we have to divide it by sigma. This is the formula. For the Z-score, this is the formula that we have to use. Both of us will be mu only. We have to write xi. This is your x value, and we transform it by the average. So let us replace it by x bar. and then divided by the standard deviation. So sigma is standard deviation of the sample. Xi, this will be your observed value or observation. Similarly, we can take here my x bar, which is your mean of the sample. So from original data, we are having the transformed value on the x-axis. We will be having the z-score, and this is how it will look like. All right. In the standard score, there are certain properties. First of all, the mu will be, in this case, your mu value will be 0. This is your mean. So again, it is showing you that it is having a symmetry around the mean, but the mean value will be calculated will be 0. Symmetrical around mean, but the mean value is 0 this time. So on the x-axis, we don't have a marks or a score or whatever the value you are taking, but rather we are having a transformed value of that particular data, which is calculated by x minus x mu. This is obviously your average, and divided by the standard deviation of the sample. Apart from this, the standard deviation will be having 1. This is fixed. For the standard normal distribution, your sigma value will be 1. For the standard normal distribution, your sigma value will be 1. Okay. Obviously, in this case, your variance will be also 1. So sigma square is also 1. Remember that this particular part, what you see here, is a continuous form of the data. And because it is a continuous form of the distribution, so there is one more thing you can calculate from this, and that is the continuous probability value. So I'll talk about it after the break. First of all, let's summarize this. That here in this case, your value will be transformed, and this is the transformed result when you see it. And these are the properties. Other properties will remain as it is. That means how much will be this? 68% of the overall distribution between z-score minus to z-score plus 1. Okay. Similarly, between z-score second standard deviation, how much value will fall under this? 95% of the overall distribution. And the third standard deviation will be your majority of the data, which is 99.5 to 99.7%. Okay. This is your empirical rule. Now from here, we get one more method to find out the outliers, and that is when you calculate the z-score for the different values, and if this value of z-score is greater than plus 3 for a sample, similarly if your z-score falls is smaller than minus 3, in both of these circumstances, the sample is having outliers. Samples are outliers. If they show you the z-score value is greater than plus 3 or minus 3, which means that the values of the samples which are beyond this range, this minus 3 and plus 3 part, they will be considered as outliers. Okay. More on the outliers part we will discuss. But before that, I'd like to take your doubts and questions. Please go ahead and ask your questions. In the first and the second, both the part. Just minimize it. Anything is not clear? See, both are same only. The differences are that one is a standard form, the other one is your just a data which is getting distributed, and we need to monitor if it is a normal distribution or if it is not. So if you have got any questions, please go ahead. Otherwise, you can respond clear in the chat window. Fill in a function is used to fill the value, a constant value, just like replace. Yes, both of these strategies are part of your continuous data. These are all part of the continuous data, both normal distribution and your standard normal distribution, both will be part of your numerical data and mostly continuous. Empirical rule will be working for all the data, yes. But the rule is only true if your data is normally distributed. If your data is not normally distributed, then these rules will be not implemented. These rules are only for the numerical data, and these rules will be only true for the empirical rule will be only true if your data shows the characteristics of normal distribution. If they are not showing any normal distribution, then no need of that. Why we have 0 as a z score? This is a mathematical value, so this could be anything. What's the problem? It could be +1, it could be -1, it could be 0, it could be minus. These are all getting calculated from this particular value. Mathematical term is there, it could be anything. And we are plotting our distribution data with respect to our different z score value. Z score is a kind of a transformation which we apply to our data set. You can call this as a standard scalar method. This is your scaling method where z score is used to transform the available features. This is part of pre-processing the data. All right, so these are your different methods which are available to us. Next is, please ask your more questions if anything is not been taken. Data set part, I'll explain what is the difference between X bar and mu. Okay, so that's pretty good. X bar is for sample. This is mean for sample. And mu is for mean for population. In maths, there is only one symbol. In stats, there are two. One is for population, the other one is for sample. That's the difference. In statistics term, X bar is used. 4 is 0. Indicates that data points to mean score value. In this case, whatever my data point will be there, this will be transformed. We will get the z-score for that, and this same score, z-score, will be equal to the mean value. Alright, so here the common is that same data. So imagine here what happened. In simple terms, it means that the value 50, this value 50, when we calculated the z-score for this value 50, x equals to 50, it means that there is this same value is having, this is your mean value, and that same value is having the z-score as 0. Also, in simple terms, if you will see the formula, of z-score, what does it indicate? X minus x bar by sigma. So what the 0 indicates here, that your value, the sample has got 0 deviation from the mean of the sample. Okay, so that's the importance of this 0 point. And obviously the other important thing about the 0 score is that this will be having a symmetrical, this will divide your entire distribution into 50% and 50%. Okay, that means this will be 50% of the overall distribution of the data, and the right hand side and left hand side, they are all getting symmetrical. They are 50-50 divided at z-score equals to 0. Okay, clear about these points? Anything else? Hopefully I've understood about these things, that what are these values are indicating, and in which scenario we are having outliers, what is this significance of the 0 point, and the formulas, the mathematical formulas. Okay, so we can stop here and we can go for a short break. Once we'll come back after the break, we can discuss about more on this. So either can I have a clear in the chat so that I can start the timer clock? Everybody is clear till now? Drop yes in the chat. Everybody drop yes in the chat if it is clear till now. Okay, thanks for the confirmation. Let's go for the timer clock. We'll see you in next 20 minutes. Polling activity, we can do it later. Already it's been 10 minutes, so let's not wait further. I'll take the polling today in the end. Okay, thank you so much. We'll see you after the break. Hello everybody, welcome back after the break. So before the break, we discussed about some of the important terminologies, and this I discussed it specifically for to let you understand that how does we compute our outliers value. Now that we have covered all these points, let us try to discuss. Clear everybody? So can I have quick responses in the chat if you are all back in the back? Okay. So let's try to discuss here about box plot thing, because with the help of box plot also we can perform our certain type of statistical terminologies like the outliers thing. If your data is not normally distributed, then remember that box plot will show up like this. It will be showing you all these quartile spots. I remember that I have already explained this in our previous topics. So, but this time it will be explained with respect to our entire points going on here. Okay, so I was talking about this box plot thing. When you just see here all these values, just look at here that this particular part will be used to divide your entire distribution. Here are my values. This is your middle term, and this is your another distribution. These are all quartiles here, right? What is the meaning of this will be your minimum value range. Lines are called as whiskers. This line is called as your median. First point is quartile 1, second point is quartile 2, third point is your quartile 3, and this last part is your max. Line is whiskers. Quartile 1 is your 25th percentile. Median is your 50%. And quartile 3 is your 75th percentile of the overall sample distribution. They're all divided as a quartiles here. So why they are called as quartiles? Because we are having 1 by 4 value. So this is your 1 by 4th term. This will be your 1 by 4th. This is your 1 by 4th, and so on. So that's how your distribution is divided here. And in normal distribution, you will see that everything is centered around the length of these whiskers will be also equal. The median will be exactly in the center line, and so on. These are the common strategies these are the common things which you will find in the box plot. IQR, interquartile range. This range is called as IQR, right? Just giving a quick overview of what we have already covered earlier. So IQR will be given by Q3 minus Q1, and what is next in this case that we need to cover here is by 25th percentile quartile 1. Okay, what is next in this case? So that we need here is the min and range. So how does we calculate the min? Min will be equals to Q1 minus 1.5 times of IQR, and max will be given by Q3 plus 1.5 times of IQR. So IQR will be provided by your value, which is given by Q3 minus Q1 and on the basis of that we get this part. So how this is related to the outliers? This is related to the outliers in this term that if your value is either smaller than the min range according to the calculation, or if your sample value is greater than max, in both of these circumstances, you'll find the box plot will show or represent the outliers, and those outliers will be presented in terms of dots, the black dot. So this is your more. This is also one of the important sections that we have already covered in our previous part. That what is the meaning of outliers? So this could be one of the way to find out the outliers section. What we have not discussed earlier was that if your data is not normally distributed, then it will be skewness. There are three forms of the skewness we are having. One is called as your symmetrical, which is similar to your normal distribution. So there will be symmetry around again the mean. But if your data is not symmetrical, then you can measure that whether it is a left skewed or if it is a right skewed data. So let us start with your left skewed. Left skewed means the tail decides the skewness. The tail of the distribution decides your skewness. So if you have got a long tail towards this, what type of distribution is this? This is called as your, if your tail is towards this side, what you can call it as left skewed. Alternative name is your negative skewness. Okay. What is the property this will be following up? Okay, so this will be having the property number first. No symmetry around the mean, median, mode, and all these three will not fall in the same line. We are having one point which is called as your median. Then we have got mean. Pardon, wait a second. We need to change the names. This has to be mode, then median, and then mean. Mode, median, and the third part is my mean. These all three are available as a distribution here. Okay, but they all not fall in the same line. That's how it will be showing up. Next is your right skewed. The next part is your right skewed. One is symmetrical distribution as well. Symmetrical distribution is similar to your normal distribution. So there are two main parts. One is your negative skewness. Now let's talk about the positive. towards this side. Define here first mode. First part will be mode, then median, and then mean. Again, but towards the right hand side. First is your mode, then you'll have median, and then we have got mean. Then we have got mean. Okay, so this is how the negative skewness is values are available here. Fine. Now in the positive skewness, what you can say that your mean will be greater than median and median is greater than your mode. Similarly, about the negative skewness, you will see the opposite part. You will say that your mode is greater than median and median is greater than mean. Okay. So that's your two different parts, negative skewness and positive skewness. This is how they will be represented. This is on score part, marks, or let's say marks again, and this will be your frequency. In these type of distribution, there is a great chance that you'll be having outliers. The long tail will decide your sample distribution here, plus the median line will be also somehow in between. The center line is your median line. Okay, and as I said, there is a great chance that in this case we will be having outliers. These are all your outliers value. Similarly, on the side, also your box plot will be created, and the box plot will have a long tail. The tail is towards this side. This will be the long tail here. Median line will fall on this side. In spite of this, we can just see it in this way. See, median line will be exactly on this part. Somehow like this. The median will be towards the near to this point. The long tail part will be having the long lines, and on your both the sides you can have plenty of outliers. This is your negative skewness plot, and the other part is your median lines and all. All these are points, and that's how the things work. Fine. So this is how the distributions look like. These are their representations. So hopefully now you understood it, that how does it work, and how does these points actually could be used to find the most important, one of the important thing, which is called as your normal distribution part. Skewness is fine. Now after this is over, then we can talk about, once this is done, then we can talk about one of the important point, and that is called as your so this is done here, everybody finished. Okay, that's great then. So now once we are done with all these points, okay. Now there are points here which we like to discuss, few more sections, and that we can discuss. So outliers part are done. Yes, kurtosis. So anybody can define what is kurtosis here and what how it is different from your skewness part? Anybody? Anyone can describe what is. Okay. This measure, kurtosis, basically measures the peakedness, measure the tendency of the data towards the center or towards the tail. Yes. So this is basically related to somehow you see the distribution and we check that what is the peakedness. So measures peakedness here. So kurtosis usually describe peakedness. Okay, which means that how sharply the data or how sharply the curve, the peak is. Fine, this is one thing, peakedness, or the other one is your heavy, as most of you are saying, tailedness. So we measure here how your data is, what is the distribution? Is the distribution is towards the peak and or the distribution is towards the tail. These are the 2 points which are used, which could be explained through the kurtosis. Okay, so there are 3 points. There are three type of kurtosis which will be there. One describing your obviously the normal distribution part. So I'll just take an image here to explain you this. These are your three different points. One is leptokurtic distribution, which will be having most of your data towards the center. Most distribution most distribution around the center. The second is your normal distribution, and so this is zero. This is not having any kurtosis value, or kurtosis value will be equals to 3. That's what we measure here. And the third one is your, if we have got the peak is less than the leptokurtic here, litokurtic, that's your third point. Most of the sample, most distribution is towards the tail. Or you can also call it as the distribution is shorter and tails are thinner in this case. Platocortic, this is the green one, right? So distribution is shorter in this case. You can call it as distribution is shorter. Is shorter, and you can see that the tails are, in this case, tails will be thinner than your normal distribution. Normal distribution has got a name, mesocortic, mesocortic, leptocortic, and platocortic. The platocortic will be having the distribution which will be shorter, the height will be shorter, and tails are thinner. Tails are thinner than normal distribution as compared to, are thinner compared to mesocortic. Or mesocortic, you can say also the normal distribution part. So peak is lower and broader. In this case, your data will be light tail. Light tailed distribution. And most of your data falls under the center line. In this case, the peak is larger. In your leptocortic, distribution is longer. Distribution is longer. The tails are fatter in this case. Thinner tails are not there, but rather we are having fatter tails. Fatter tails are there, or heavy tails. We are having value such as kurtosis equals to 3, kurtosis greater than 3, and kurtosis is smaller than 3. Leptokurtic, the long tail will be having kurtosis value which will be greater than 3, and platokurtic, in this case you will be having kurtosis value smaller than 3. Mesokurtic, that's your normal distribution here. So once you are having kurtosis value greater than 3, then you can call it as that your data distribution is most of the distribution is around the center, and the distribution is longer here. Hey, wait a second. Still true for the next one, right? Not this one. This will have around the tails. Yes, 3 is related to your Z score actually. Okay. We call that kurtosis is particularly called as your standardized fourth movement. That's why we take the greater than 3 or smaller than 3. So it's related to your Z score. So this is your standard rule that if it is greater than 3, or if it is smaller than 3, according to this, we say that if your data is leptokurtic or platokurtic. Okay, clear all these points? I think this is enough for today, and let's apply them in practicals. And we will also do a lot of a heavy visualization part to explain these points. So these are all important terms that we covered today. I'll share this as a part of notes. Okay, so you might receive it this week. Sorry, upcoming week. Okay, let's go to our main point, which actually started all this discussion, and that was the outliers and how to find it, how to find our outliers value. I think somebody is, so let's try to discuss it in terms of how to calculate our outliers part. So let's discuss it. Let's take our value here. So we can take some values here in this case. Just give me a second. Need some water. Okay, let's continue here about our outliers part. In this case, I'm just discussing one part of the data visualization because I think it will be good if we can discuss some here. And that is your box plot. Box plot is an important way to find the outliers part. And apart from that, one more plot which will be really important is called as your scatter plot. So those both the plots I'll be discussing here. These are again I'll discuss it after this. So one of the important plot libraries are matplotlib, matplotlib.pyplot as PLT. Next is your Seaborn as SNS. These are two important libraries here. Seaborn as SNS. So import Seaborn as SNS. Let's import them. The data visualization will be our next topic. So that's quite an important one. Let's get started. Import matplotlib as PLT and import Seaborn as SNS. Now that first we will try to target the price part. Let us say the price section. So PLT. PLT is indicating here pyplot. Okay, pyplot is a path. Matplotlib is a understand matplotlib is a bigger folder. Inside that there is a subfolder named as pyplot. So that's how we take this PLT dot figure. Take here PLT dot figure, and then we write here fig size, which is equals to 11, 5 SNS dot box plot. Okay, so we have taken here a figure size. Figure size is your height and width. Remember that these will be again explained. The best way to calculate the box plot is using Seaborn library SNS. In this we have got box plot function straight away, and we can pass the data equals to auto price and price name. I have written here orient equals to h, which means that I have made the plot oriented towards the horizontal plot. By default, the orientation is vertical. So orient means orientation. Okay, the rotation, orientation of plot, and h means horizontal. H means horizontal. So this is all my plot here. Let's get started. Okay, where are my box plot in this case? Where are my box plot here? Box plot is representing by black dots. Okay, just remember that we are having two important libraries. Both libraries are used for the visualization. Okay, whether it is matplotlib, these are your packages or libraries which are available to us. The matplotlib library and the Seaborn both are doing the same thing. Also remember matplotlib and Seaborn, they complement each other here. And whatever the package that you are using here, in this case the matplotlib package if you are using or Seaborn you are using, the transformations if you will do in this, the other will also accept it. Okay. Right now in this case we have created a simple plot with a Seaborn package which offers us a function called as box plot. And in this we just pass a single column which is a price column. If you will pass a lot of multiple columns you can pass as well, so they are different box plot could be represented here. Okay, there is one more thing here which is important, which is called as your plt.figure. Now plt.figure is a inbuilt function from plt means what? Plt is representing pyplot, matplotlib.pyplot, correct? Whereas SNS is a standard name which we use as an alias to represent that it is a Seaborn. Now that we have written here plt.figure and we have mentioned here my figure size. What is my figure size in this case? 11, 5. What is 11, 5 here? That's the size of the figure. Okay, that's the size of the figure. This figure is by default. What happens if you don't mention here? Then you'll get a default size, which is a pretty small one. So if you are happy with this size, then it is okay. If you are not happy, then you can control the figure size by these numbers. So one shows you the length. Obviously, this 11 is showing you the length, and 5 is your width. So height and width, that's what we get from the figure size. I'll just add this as a comment, and you can add it at the top so that you can later change your figure size according to your. So first is your width, and second is your height. I'm just sending it. Okay. Where are my outliers in this case? Black dot. Okay. Ignore the black dot. First of all, tell me what type of distribution this box plot is giving us. What type of distribution is this? Is it normally distributed? Is it skewed? If it is skewed, then what type of skewness is represented here? I want the name of the skewness. If it is skewed, then you have to tell me whether it is a positive skewed, whether it is negative skewed, and write your answers in the chat. Quite simple. Where is the tail? Where is the long line? The whiskers. Just now I discussed it. So where is the long line? Long line is towards the positive side. If the long line is towards the positive side, then it will be either right skewed or it is positively skewed. If this same line will be towards the negative side, towards this side, then it will be called as your negatively skewed. So this is positively skewed data. So one thing is pretty sure that your this price is not normally distributed. Okay. Next is, so let's try to figure out. Let's try to find out the outliers. So we can take here auto price, and we can take here my price value. This will be equals to, okay. Price is already a numerical data. I think we need to just check it. I think we already converted them into float. Okay, that's great. So what I can do here is I can simply write here quantile. Now we call it as quartile, but we are having a function called as quantile. What is the meaning of quantile here? The same quartile thing, and dot 25. This is called as, what is the other name of this 25th percentile? Quartile first. This is your first quarter. Q1. Okay, next. Q2. What is my Q2? How much percentile, guys? Participants, how much percentile? Q2, 50th percentile. Okay. And quartile 3, 75, so 0.75. So we need these two, and with the help of them we can calculate our outliers. I'll be interested in creating actually a function named as find underscore outliers. This is a better way of representing the outliers part. You can pass here the columns. Now first of all I'll put here these two formulas, and then we will calculate the IQR with on the basis of this. Let us replace this price by calls. Let us replace the price by calls. Then we can take here IQR. IQR will be given by Q3 minus Q1. Then we can get here my minimum range, which is equals to Q1 minus 1.5 times of IQR max range, which will be given by Q3 plus 1.5 times of IQR. Then we get here my outliers indexes. So we can call it as indices here. Indices, outlier indices, which will be equals to auto underscore price, and we take here dot index. Okay. In this case, we can take here auto price, and we can place my columns, and we'll find if this is smaller than my min range, or if it is greater than max range, or if it is greater than max range. In any of these scenarios, either your value is smaller than min range or your value is greater than max range. What will happen? That will be considered as my true conditions. These will be my true conditions. So condition number 1 and condition number 2. So this is like my customized code to find out my value in spite. Okay, now in this case I have not passed the data frame name. If you wish, you can just pass the two attributes here. One could be df and the other could be your columns. So wherever we have written here auto price, you can replace it by df part, and then in that case you have to pass your values accordingly. So this will be like more customized function, which you can use as it is to find in other data sets as well, right? It is taking two arguments. Okay, and now that we have figured out here all these values, let us just use my function and let's pass my two values here. So find underscore outliers, and there has to be my two details here. One will be auto underscore price, and the other part will be my price. Okay, sorry, my bad. We should return here outlier underscore indices, and these are my index positions which are representing the outliers value. Those are those black dots for a specific column. I'm just sending you the code now. So this function you can just use as it is for the other data set as well. That is that sample code. Next is I'll be using here one more method we have discussed, and what was that? Z score. Some people are still stuck. Those who are getting this error, which means that you have not followed the code properly. Yesterday I have already discussed about how to handle this question mark. So if you have not done, then just it's better you observe it. When I'll share the code, or when you can go to our previous recordings, then only you can proceed. This was a part, and there were many in between things. We have also converted the data into the numeric part. These were the two things which we discussed already yesterday. So if you have not done, then that's the reason why you are getting this type of error. Could not form this question mark and all these type of things. Okay. So all of you complete this, and you can just respond yes in the chat window. Once you have finished, you can just write down in the chat. Please write done in the chat if you have finished. All of you complete them, complete these points and drop done in the chat. I'll discuss about how to see outliers are noisy samples. If they are less in value, then okay, let everybody complete. Then I'll discuss in general that what to do with the outliers and what could be the different strategies which we can apply. Everybody finish it and write done in the chat. You can also pass a list of numerical columns as well, yes. But then along with that, you have to make sure that you have to iterate it one by one, because the function is for one function at a time. Okay. So generally, our outliers will be one way of finding it like this. The other way will be that when your value exceeds the z-score greater than 3, right? The value which is beyond this will be also treated as a outlier. The values which are in this region, they will be considered as outliers. These are all called as your outliers part, right? From the z-score we discussed it, we clarified it that if your value is greater than 3, z-score is greater than 3 or smaller than 3, then they will be considered as outliers, and in terms of IQR, it will be about this. Now, coming back to this point that we have understood the outliers, but what are the different strategies you can do? So, either you can particularly make a strict boundary that any value which is, you can create a cap actually, that we are having a ceiling value at this and floor value at this. And if any value exceeds this, that is our outlier, and we will simply drop them. So that's one of the strategy. The second one is you can do, so I'll just talk about here treating outliers. Correct. What are the different strategies that you can apply in this treating outliers part? This will be only theoretical part, because obviously we have discussed a similar type of thing in our missing value section as well. Replacing part. So one could be like removing the value. So you can simply drop these rows, remove or trim the outliers. So suppose we have got these indexes, right? So what you can do is you can simply pass this indexes value into the drop function, and that will do your trimming part. It will help you in getting rid of those outliers. So if your outliers count is less, then only this treatment is fine. The other one could be you can just trim the data. You will not, you will just trim the sample in spite of taking the value, the entire sample. You can just take the value here. Okay, we will just take here a simple value that will fall under this range, which is your 10th percentile to 90th percentile. So trim the data. You can just say that you will take between 5 percentile to 95th percentile. You are just taking the sample data that falls under this region. You are not taking the data beyond this. That could be one thing. Next could be, the next part is mean oblique median imputation or applying imputation using your central tendency of mean and median. These could be your 3 different points or strategies of treating the outliers. Now that we have discussed about all these points, Shanura Sheikh, your values are not trimming anything. I think you are getting something else. That's definitely not outliers. These are non-outliers value, I guess. This is opposite of the outliers, I guess. Not sure about what exactly you are getting, but that is not your outliers. Yes, it is one of the. I'll just send you the function. Please take it. Yes, we can apply the imputation method by mean and median. Next, let's talk about the Z score or Z score here, and let's try to find out our outliers with the help of Z score. To find out the Z score, we need to take the help of SciPy. Import SciPy, from SciPy, import stats. From SciPy, import stats. Import numpy as NP. Okay, so in this case, what we are supposed to do is we have to just take our values, and we will take here my stats dot z score, stats dot z score or z score. We'll take here my value, and in this case we will only pass those values which are numerical type, the numerical columns. So how to select the numerical columns? I'm giving you a small task. Write me the code to select a float and integer value. Give me the code that will give me only those column names which are numerical type. Give me the code that will give me the result, only the numerical code, the numerical data type. Yes, that's correct. I think one closing bracket is missing in your code, not exactly what you have written. Oh, I have not mentioned the square brackets. No, it is fine. So this is my numeric columns, and remember that these part will be only applicable to the numeric column only, and that's my numeric column here, auto underscore price underscore numeric. And that's what we can pass here. These are all my different values. What I'll do here is I'll just try np dot absolute value abs. Okay, so that's all will be stored as my z score value for the different data, for the different columns. Sorry. Now using np dot where, we have to find out using the z score where it is greater than 3 or where it is smaller than 3. Smaller than -3 and greater than +3. These are particularly giving me those indexes. So it returns you the indexes where your z score value is greater than 3 or where your z score value is smaller than 3. So we can just consider here z score, if it is greater than +3 or my z score value which is smaller than -3. Okay. So using np dot where, what are we returning here? This will be returning you the indexes. These are returning you the indexes. These are returning you the indexes. Fine. So these indexes value which we are having, again you can easily drop these positions. This is your outliers that are available to us, and you can just put them in your data, and you can simply drop them. That could be one strategy. The other could be you can simply replace it by mean or median strategies. Remember, your median and your mode, they are less getting, they get least affected by the presence of the outliers, right? I think this part I have described earlier as well. I think in chapter number 1 or 2. So median and mean, these are those parts which are less affected by the outliers, the presence of outliers. Median will still be get affected, but mode is unaffected. I mean, mode is the most frequent value, so that will not get affected here. Okay. And while talking about the trim of the data, I have considered here this as a example. So this could be any range. You have to just look at your range value that which satisfies the trim data. It could be sometimes 10% to 90% as well. So you have to look for these values and then decide. This trimming part is up to you. This trim of the data and removing the trimmed outlier, it is up to you. If your number of samples that you are losing is less, in that scenario only you have to trim the data, and then you have to again check whether all your outliers are gone or not. This part is subject to the size of the data. This part and this part. These will be subject to your data set. Here the Z score is calculated for more than one columns. If you wanted to know that which particular column is available for which particular indexes, then pass one column at a time and then get the value. That is the best way to find which indicates which indexes. And absolute value ABS is absolute. NP dot ABS is absolute. Okay, absolute value. ABS stands for absolute. Just now I explained by 5% or 95%. This is not strictly you have to take it. This is these two part is subject to the data set. Please pay attention. This two section I have already explained. This is subject to the data set. Depends if you how much data you are losing. If you are losing less number of data, you can also choose these values and you can also increase these values. These are not strictly 95% to 95%. This could be 10% to 90%. We are trimming the data. So we have to look for how much within which percentage of the, which within which number of percentile we are getting the output that has got 0 percentiles. Sorry, that has got 0 outliers. So that's how we discussed, and yeah, that's how it is. So everybody finished, and hopefully you have understood all the key concepts behind the outliers. The best way to handle the outliers, you have to look for it, and then any one of these three could be used. Okay, now that we have covered all these points, we are done with this section. I think in pandas, I was just looking here, there was one point that I have not discussed, and that was group by, I guess. So I think that I'll discuss here in the group by part, here only. That's simple, just it will give you the group by and view counts. Why we are getting two arrays. That's related to the np.where, which is an inbuilt function here. Okay, numpy.where function is there. Now, this is particularly going to return you the indices value, and this is what that indexes represents here. This is what the indexes are representing in this case. Okay, so other value will be maybe some value or something, but this is what our target values are. That's what you have to see. Only this highlighted value, where we are particularly using the np.where, and this will be particularly returning you the indexes. So the first part is your indexes part, which is returned from the numpy.where function, which will return you the indexes. In an array form, it will be returning you the indexes. Okay, so this is what your indexes are, and you can target them. For different columns, we are getting same indexes because they are different columns. They might be returning it. First of all, this is what your indexes are. These highlighted value. Okay, so just look for this part, and remember that these are showing you the different the sum of the values are getting repeated, and the reason is pretty simple, that there are multiple columns. In this case we have passed, so they will give their own different indexes. The other column will also give their outlier values, outlier positions. So that's why they are getting repeated here for all the different multiple columns. Okay, I think this is more than okay. One more way to find the outliers. Sometimes we, as I said, that trim data part, right? Some part is could be done through the other way around. So what we can do in this case is that we can, instead of going for just z-score value or this outliers part, we can also target some data visualizations. One is like a scatter plot here, and using the scatter plot, we can actually create a function, and we can trim the data according to that. Okay. So before we go for that, I think it's better we start a new Jupyter notebook and start with some visualization, and then I'll come back here to discuss that. Okay, there was one function here in the pandas part that I had not discussed earlier or yesterday. So I'll just simply use here my auto underscore price. This part was not discussed or what? Kernel, restart and run all. What was the name at the top? Auto underscore price. Still there, same. Okay. So I go for here auto underscore price. I was saying here that we can just simply perform a group by. While taking the group by, you can just write here group by. You can pass here some column name. Let's say my column name as a categorical column you can take. Maybe group by I like to take here group by makers make. So we can take here auto price group by make, and your data will be grouped by here by the makers. Now in this case, once you have group by, you can get the all results here. You apply the group by and you can just pass here dot first. When you pass here my first value, you will see the values, and they will be showing you the result in terms of group by. Here you can see makers Alfa Romeo, Audi, BMW, Chevrolet, Dodge, Honda. These are your data which are available to us, and their grouped by result. And their grouped by result is available. The first value of each group. The first value of the each group is available here. So by taking the group by, you can also try to find out other functions as well. Okay, first will particularly give you the first row of the data. So this type of function also you can apply, which will present your data in a group by format. You can also use multiple groups here. Generally in the group by, we use here categorical data, or if not categorical, if you have a numerical value with a discrete type of data, then it's okay, you can apply that as well. So suppose I'll be changing it to my body style. Okay, body style, this could be also added here. So make and body style, and then we take here first. So maker Alfa Romeo, body style is convertible. This is your first result. Hatchback, first result. Similarly, Audi hatchback, sedan, wagon. BMW sells only sedan. There is no convertible or there is no hatchback. Chevrolet hatchback, sedan, both are there, and so on. So for every country, for every makers, you are getting their category. They are getting further getting categorized as according to the body style. That's the purpose of multiple group by operations. Multiple group by operations. So you can run them and execute them to get your results. It's better if you can paste them in the pandas part, the package that we have used yesterday. If not, then you can continue in the same data wrangling section, and that's what the cleansing part is all about. Now we'll start with my new notebook. Sorry, I already started it. And this new notebook will be dedicated for the data visualization. This is your another lesson, I think lesson number 10 as per our older part, data visualization, and majorly in this case we will discuss about two libraries, matplotlib and seaborn. These are the two important libraries that we'll be discussing. Using two important packages, matplotlib and seaborn. Now, after we will covered with all these packages, then we will be done with our basic packages, which are the key important section. You can also call it as better than this. You can also call it as an EDA part, exploratory data analysis. Better you can call it as exploratory data analysis. That's the term which we use. EDA. Matplotlib library. This is particularly for my data visualization library. One of the important library here, data visualization. Similarly, we have got seaborn. This is for complex plots. Descriptive plots in spite of that, you write here descriptive plots, which shows the description of the data. Descriptive plots made easy with the help of seaborn. Basic plots made easy by the help of basic plots means the line plot, histogram, all those type of different plots here. So basic plots made easy here. That's the difference between these two important plots packages. These are the differences between these two packages here. Now in this case, we will cover an important section of our data visualization part, an EDA part, and we can consider the same data set that we have discussed. Anyway, let me give you the explanation for this particular new chapter that we are starting. Data visualization, that's lesson number 10. According to me, this should be first covered and then we can go for the other chapters. This is the basis. So let's get started with the data science of the data visualization part using matplotlib. Now, what is a data visualization first? We need to understand this. Data visualization is a technique to present the data in a pictorial or graphical format. This is a technique where you use the data and you make sure that you will present the data in such a way, in a pictorial form, in a visualization form, which will help us to identify the trends, patterns through the help of the data set. Okay, like through the pie chart, you see the distribution of product. Which product are having the much more market sale and which particular product has got the least product sale, right? Next, through the line chart, you can actually get the idea about whether your sales are having upward trends or downward trend. Okay, that's one thing here that gives us the data visualization. So how this data visualization, and most importantly, why we will say that the data visualization will be important to us? Because this is something which help us in finding the hidden insight, of the data set. of the data, patterns, etc. For example, let's take an example here that you are a sales manager in a leading global organization. The organization plan to research the sales details of each product across all regions and multiple countries. This is to identify the product which has the highest sale in a particular region. This research will enable the organization to increase its manufacturing of the product in a particular region. So according to that, you have to manage the logistics, right? You have to manage. You have to first monitor the sale, and then you have to monitor. Then according to that, you will make the decision of manufacturing and the logistic part will be highly dependent upon this plot. Data involved for this result might be huge and complex. The research on the large numeric data is difficult and time consuming when it is performed manually. Obviously, if you have been given with a millions gigabytes of record, you cannot see that gigabytes of data and you can find anything out of it. You need something fast and something more relevant here. So when your numeric data could be plotted here on a world map, then in that case, what you can do is you can simply change the circle size. Maybe I'll just give you a hint here that you can change the circle size here, size of the circle, which will be dependent upon the sales. So if in a particular country the sale is more of a certain product, their circle will be bigger as compared to the country or the product which is having a low sale. This will be one easy method to use the visualization in this case, so that you can identify that which country is consuming which particular product, and you can obviously present them in different colors here, product A, B, C, D. The main benefit of visualization is that it simplifies the complex quantitative data information which is available to us. It also helps us to analyze and explore the big data size. The humongous amount of the data could be easily represented here. It identifies the area that need your attention and improvement. You can also find out the details like whether you are having the seasonality part, right? This example I have explained this part earlier as well, that if your plot has having some seasonality, after every certain interval your sales pattern is getting repeated. It also identifies it identifies the relationship between the data points and the other variables. It explores new pattern and reveals the hidden patterns in the data that could be also explained through your data visualization part. Okay, so I think this is the same question, and it was the different answers that we are trying to find. Next, the main benefit of data visualization, we just discussed about it. Okay. Consideration of the data visualization, three major considerations are there. First one is clarity, the second one is accuracy, and the third one is efficiency. Ensure that the data is complete here and relevant. This enables particularly the role of the data scientist to use the new pattern, and whatever is obtained from the data is relevant. So clarity, it ensures that the data set is complete and relevant, and make sure that your data scientist will use this new pattern obtained from the data in the relevant places. Second part is accuracy. So secondly, ensure using appropriate graphical representation to convey the right message. We have to understand that the different plots cannot be used to describe the similar type of data. Some plot are there which are like, let's say, bar plot. They are used majorly to describe a certain type of data. Then we will be having a data set which could be which could be helpful in explaining, could be explained through the help of histograms. Then third part is my efficiency. We use efficient visualization techniques that highlight all the data points. So that comes under your efficiency section. Factors of the data visualization. The basic factors that one need to aware about before applying the visualization of the data are visual effect. So visual effect will include here the uses of appropriate shapes, color, and sizes to represent the data and analyze the data. So we will discuss it. We can all control these shape part or the sizes of the plot and color of the plot. These all can be controlled by your PLT or Seaborn. Seaborn. So these two are the packages which are used to represent your data with the help of your visual effect. Next could be your coordination system. The coordination system helps to organize the data point within the provided coordinates. So in this case particularly it is talking about here the x-axis and the y-axis part, and if required z-axis. So up to 3-dimensional you can do the visualization, and after that it is not possible. The data types and scale chosen chooses the data type, the type of the data such as numerical, categorical. For categorical, generally we use plot like bar graph or categorical plot. You can call it as cat plot. Similarly, for the numeric one, we use distribution plot, and you can also call it as your normal distribution. You can find out with the help of this the normal distribution plot, etc. Okay, factors of data visualization. The informative interpretation helps to create visual in an effective and easy interpretable manner using labels, title, legend, and pointers, etc. So these are the important factors which you have to take care, and that is what this session will be all about. The different libraries that support your Python part. So out of that, the visualization could be done by 1, 2, and 3. These are most important one. Rest all are also used, but they are not much more popular. Folium is also there. Folium is used for the world map. Folium is for world map. Like you saw at the beginning, this world map could be easily created with the help of library called as Folium. But by default, most of it. Line plot is easily used for showing us a representation in such could be figured out, could be used. If you are using this line plot, then these are the two important things that you can use. Relationship between the two numerical values and the univariate plot as well. Okay, let's do this. Let's discuss it on the next plot. While you finish it today, let's have some plots ready. Same data set, I'll continue. Okay. Let's keep our data set same. No need to change them. So you can copy it from your previous part, whatever the data we have taken. But yes, in this case, we need to make sure that we first prepare the data in such a way that this time we should be having our data in a numerical format. Missing values we are not worried about. That was already been taken care here. But yes, what we are worried about here is that we should able to see all our data to be available in a numerical format. This is important here, that we should convert our values into the numerical format. And as you will apply these columns into the numeric format, bore, stroke, horsepower, peak, RPM, and the price, as we applied here in this case, the question mark here, I think we can add here in this case an argument course ARGS equals to course. No, it's not working. Sorry, comma. Okay, now this will be helping us to get rid of those error here. So that is just for one example because we already had this question mark thing, right? So this is to handle those unwanted elements. Please copy the data type, sorry, the path of the file from your own location. Don't copy my location, so I'm not sharing this part. You already know that how to read the data, so you'll just simply apply these. In this case, this extra bit of things we have added course because we are having that question mark error. So to handle it, we have to use this option. Other options you can easily find out with the help of that shift and tab option that we have already discussed it. Okay, now what we will do here is that we will particularly now after this, let's target our auto price and let's see our null values is null.sum. You can see that these are the values which are been visible here. Normalized losses are been already handled. They are non-zeros here. Now because the number of samples are quite less, which are having missing values, so we can easily apply which method? Remember what particular method we can figure out? Drop NA, correct. We can apply here in this case drop NA function, and we can also update our value by using in place equals to true. So easy pickings. We can just use here data types. So I think till the auto price dot is null sum. So this is one thing that we can apply that will handle your missing values. And now we are ready to make a plot. So if you wanted to do it in just in a casual manner,